Hi everyone, this is Basics of Absolute Value Functions. This is preliminaries to solving absolute value functions, and we're just going to talk about some of the properties by analyzing the graph. And we have f of x equals absolute value of x, and basically all that means is, for example, the absolute value of negative 3 equals 3. And it's in use, for example, if you were going underwater, say 3 feet, that would be considered negative 3. So you take the absolute value to see the exact feet you went down. You only went down 3 feet, but if you're but since you're going down, it's called negative, but it's actually 3 feet. So it's for things like that. All right, so here's the parent function, and it's important to note that basically I'm going to write this as in two pieces, and I don't want you to get confused with this, but it's a very important concept, especially when you get to calculus, that basically this is the definition of absolute value. It means it's x when x is greater than 0, all right, and negative x when x is negative. So, and it's just 0 when it's 0. So, for example, this is obvious. So if I put in a 1, absolute value of 1, let's make it 2. Absolute value of 2, I use this piece to plug it in because 2 is bigger than 0. And that will just equal to x, which is 2. However, if I have negative 2, then I plug it in to this equation. And so that would be equal negative times a negative 2 equals 2. So the absolute value of negative 2 is 2. All right, some properties. This is absolute value function graph. It is a function because for every x, there's one and only one y. It's not one-to-one. It doesn't pass the horizontal line test. That means if it's 1-to-1, if it passes, it doesn't pass the horizontal line test, meaning it hits at two places here. It is a function because you test it with the vertical line. You draw a vertical line down, and it only hits one place on the graph. That means it's a function. All right. Next, it's symmetric about the y-axis. Here's the y-axis. It means I can fold this up on the y, and the pieces should match. What else? The domain, my x values. So on the first page, we looked at the values. Well, I can put any values I want for x. Anything. Negative 2.2, negative 1 million, and I will get 1 million. So my domain is all real numbers. So the domain is all real numbers. My range, no matter what values I'm going to get, my values are going to be 0 or greater. So it's positive numbers including 0. So my range is y is greater than or equal to 0. Or you can write it as 0, infinity for interval notation. It has an x-intercept here at 0, 0. That's the x-intercept. It's also the y-intercept. Where is y 0? Right here at the intercept. Where is it less than 0? Nowhere. So that there's no values where y is negative. Where is y greater than or equal to 0? And that would be right here at its y values here. Where is f of x increasing? Well, it's increasing here. So we look at the arrow here. It's increasing right along here. So that's it. It's increasing from 0 to infinity. And where is it decreasing? it's decreasing from negative, we can't equal it. You never can equal infinity, so it's decreasing from negative infinity to 0. And on increasing and decreasing values, they should both be open. So it's increasing from 0 to infinity. There's no maximum value. There is a minimum value at 0, 0, and there are not any asymptotes. Okay, so the next thing we're going to do is look at the vertex form of the absolute value, which is y equals, or let's do f of x. F of x equals a, which is your amplitude or your slope, absolute value of x minus h plus k. All right? The vertex is h comma k. So let's do a few examples of this. Remember, this is our formula, and if you want, you can go ahead and change that to y. So basically, if I move the k over, well, let's just do some examples first. Okay, so if I do f of x equals 3 times x plus 4 minus 5, my vertex is at -4, -5, because that's my hk. And notice that this follows the form of x minus a -4. All right? So that's a horizontal shift to the left by 4. And then we're going to shift down by 4. And we're going to do some graphs in the next video. Or actually, I could graph one of these if you want. Number 2, we have f of x equals -3 times x, absolute value of x minus 2 plus 4. So my vertex would be -2, or +2, 4. And let's do this one. F of x equals -6 times absolute value of x plus 3 plus 8. And my vertex is at -3, 8. And the last one would be f of x equals 6 times absolute value of x minus 7. So 7, let me draw a line there, minus 9. And these are my vertexes here. Let me put V here. So my vertex follow in this column, and that would be 7, -9. Okay, one more little note on this. So let's say I had, I'm going to write this as y this time. Y equals 3 times x minus a -4 minus 5. Okay, the vertex is going to be -4, -5. Again, this really, since two negatives make a what? A positive. Now, technically, we could write this as y plus 5 equals 3 times x plus 4 minus 5. The -5, as you notice, goes with the y. So, in this case, you do the opposite on both of them. No, that shouldn't go there. But by convention, we move the 5 over, and that's why it's opposite. So they're both, this is really y minus a -5 equals 3 times x minus a -4. And that's why you see the opposite thing going here. Okay? Because then they turned out to be 5. But they're both negative. So you see the negatives here. Okay, the next video we're going to graph these functions, and I'm going to graph about, say, 5 functions with transformations. Okay.